It may seem basic, but as a software developer, your primary job is to maximize the predictability of your program. Think about it. The root cause of any bug you've ever experienced was because the expectations of the developer diverged from the reality of the program. Assuming this is true, it's not unreasonable to think that we should spend at least some time thinking of how we can make our programs more predictable. Now, to better figure this out, I think it would be beneficial to narrow our scope just a little bit.
So alone.
Make our apps more predictable is too broad of a goal to be of any practical use. Instead, I think it's safe to assume that we can make our apps more predictable by making the individual pieces that make up our app more predictable. And what are those pieces? Usually they're functions. A function is a process which takes some input, an argument, and calculates some output, a return value. Functions, by definition, are simple. The problem is nothing screws up the simplicity of a definition quite like the complexity of reality. In reality, functions are often the junk drawer of our applications. In the real world, we can solve these sort of eventually chaotic scenarios by having a strict set of rules and then diligently adhering to them. Are there a set of rules that we can make to keep our functions from becoming unpredictable over time? To better answer that, let me ask a different question. What makes a function unpredictable? If we can answer this question, then we can create a set of rules to avoid those scenarios. In my opinion, there are two big offenders: side effects and inconsistent outputs. Let's look at side effects first. Earlier, we defined a function as a process which takes some input, an argument, and calculates some output, a return value. Anytime a function does anything other than this, it's said to have a side effect. Take this simple function. It both relies on state other than the input it receives, and by mutating to-dos, it creates an observable change to the program, therefore it has a side effect. Now what about this one? It doesn't create an observable change to the program, but it does rely on state other than the input value it receives. And yes, state from an external API still counts. Therefore, this function has a side effect. Now what about this one? You probably get the idea by now. We're not relying on state other than the input value it receives, but we are creating an observable change to the program. Therefore,
it's just a side effect, they say.
So why are side effects bad? Well, they're not necessarily bad, they're just unpredictable. One problem is because they depend on the context outside of their local environment.
I'm lost! Where's the line? It just went away. Dude, what do I do? Help!
They're contextual to the current state of the application. If the state of the application changes, they'll behave differently. Take this function, for example. This function will only work in a program where tax rate is both a variable and that variable is a decimal. If tax rate gets mutated, or worse, deleted, calculate final price will behave differently.
Unpredictable.
And with that, we have our first rule: avoid side effects. The next culprit in making functions unpredictable are inconsistent outputs. If a function doesn't have a return value, it's unpredictable. In this scenario, you can assume the function is either doing nothing, which is unlikely, or it has a side effect, which breaks rule number one. Similarly, if a function, given the same input, doesn't consistently return the same output, it's also unpredictable. There are a variety of built-in methods you probably use regularly that are unpredictable for this exact reason. And it's not just built-in methods that have this problem. Take this function, for example. We already know it's unpredictable because it breaks rule number one, but beyond that, it's even more unpredictable because, given the same input, it will return inconsistent outputs. Even if everything goes right, the promise we get back from GitHub profile is different for each invocation. And worse, if something does go wrong, there are a variety of other things that aren't the user's profile that might get returned. So now we have our second rule: keep your outputs consistent. So what exactly are the benefits of following our two rules? Well, it's obvious that writing functions that follow our rules will make them more predictable and therefore less susceptible to bugs. However, in doing so, there are also some other non-obvious benefits. Because these functions don't depend on the context of the application and instead receive their inputs via explicit arguments, they're entirely program agnostic and therefore extremely composable and reusable. Next, because these functions always return the same output given a certain input, the results can be cached. Say we had an expensive isPrime function that calculated if a given number, n, was a prime. This function is entirely predictable. It doesn't contain any side effects, and given the same input, it'll always return the same output. In this scenario, it doesn't make sense to invoke isPrime more than once for a given number. Invoking isPrime passing in 997 is always going to return true no matter how many times we run it. Because it's predictable, we can cache the result. With this change, one thing you may have noticed is that isPrime is now technically an impure function since it depends on the context of the application, specifically prime cache. This is a good example of how, in the real world, you can't always write pure functions. With that said, notice that we've encapsulated isPrime and prime cache into their own module. The only way to modify prime cache is via isPrime, and no other function in our application has access to or depends on prime cache. Even though isPrime is technically impure, it's about the purest impure function we can write, and I'd still consider it pragmatically predictable. Next, because these functions are free of side effects and don't depend on the context of the application, they're optimized for testing. You can simply test that, given a certain input, the output is consistent with what you'd expect. Now, if it's not already obvious, this idea isn't a new concept that we've invented. Instead, we've essentially recreated the functional programming principle of pure functions. A function is considered pure if it contains no side effects and if, given the same input, always returns the same output. By embracing and striving to keep your functions pure, you'll naturally increase the predictability of your program while minimizing the amount of bugs it has. So, what does this have to do with React? Let's find out.
Do not panic! Do not panic! We are trained professionals! Now stay calm. We are going around the leaf.